So for this, we're actually going to use the fact that this is, remember, if you do a square root, it undoes a square. So if I had x squared and I square root, remember, those undo each other. Those are called inverses. They are inverses of each other. And it's like we're going backwards. So I'm going to try and explain it the way I explained it in class. For the other one, when I had x squared, we'll do this in green. When I had x squared, I would go over 1, up 1. So, and then when I had, well, if I went over 2, I would go up 4. Or over 3, I would go up 9. This is going to be the same way except for backwards. Instead of, we'll do the square root of x. And I'll actually write it down. Over this one, this first line stays the same because over 1, up 1. Because if I plug in 1 here, the square root of 1 is 1. Now, instead of going over 2 and figuring that out, I would actually go over 4 and up 2. It's backwards because they're inverses of each other. So here, like these are switched around because they're inverses, but over 4, if I plugged in a 4 here, what do I get? Of course, I get 2. The square root of 4 is 2. Over 9, right, up, well, square root of 9 is 3. Yeah, it's an inverse. So the next one, if I wanted to do even more, I would go over 16, up 4, over 25, up 5. I would put in perfect squares because that's easiest to graph. Of course, I could put in a 3 or a 2 there, but the square root of 3 or the square root of 2 isn't an even number, and it's a irrational number, and so it'll be a little bit more difficult to graph. So we don't do those ones, but you can. Of course you can. So to do this, there's nothing on the inside here. There's nothing added to the outside. So I start at 0, 0. Just like I did with the parabolas. And now I follow this pattern, where I go over 1, up 1. Over 4, up 2. Over 9, up 3. And so it looks like that. And it's a little bit curved. All of these graphs with the square root, they're going to look like this. They start at a point, and then they go up and out. Like that. There is no arrow over there, so don't write an arrow. It starts at a point, and that's because we can't plug in negative numbers. We can't plug any negative in here because then we get imaginaries. So there you go. That's the graph of that, and we're going to follow the exact same rules for the next ones using this. The exact same rules for the translating parabolas. So here we go. Let's take a look at this. Of course, this means that we move to the right 3. It's the same exact rules. So we move to the right 3 and up 1 because we have that 1 there. So it's the same exact rules. This is my new starting point. So now, when I follow this, I'm actually going to start from here. So what does this say? Over 1, up 1. So I start here, and then over 1, up 1. And I'm moving to the right. I don't do it to both sides. And that was because, remember, I can't plug in negatives, so there we go. And then, again, starting back from my vertex of the radical function, over 4, up 2, 1, 2, 3, 4, up 2. And if I had 9, I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3, 1, 2, 3. So it would look like this. Remember, it starts there, so I can't have anything like that. That's not correct. And then it just goes over. And it's always going to be going to the right for this. If we wanted it to go to the left, then we'd have to put a negative in there, but we're not going to worry about that for right now. So there you go. All the rules are the same. Now we just need to figure out what happens when we have a negative on the outside. Remember, when you had parabolas, all of those just changed to down. So if that's what you think is going to happen here, you're right. You're absolutely right. So that's what we're going to do. Except for we're going to take a look at this example. So here we go. First, we don't have an inside there, so we're just going to have, we're not going to move left or right at all. But then it says down 3, so I'll go 1, 2, 3. That's my new vertex. That's where I'm going to start. 1, 2, 3. So that's where I'm going to start. And now this negative makes this pattern change to where it says down there. So that would just be over 1, down 1. I almost went up. Over 2, no, over 4, down 2, and over 9, down 3. And there you have that. So now, there's my graph. So that's what these functions look like. They're very simple. Now let's figure out the domain of these. It's going to be kind of hard to do it with this type of video, but let's look at the domain here. Remember, the domain are the set of all x's. So this is how I think of it. For domain, you pick a number on the x-axis. So let's say I pick something over here. If I go upwards or downwards, do I run into my function? The answer is no. That means it's not part of my domain. So actually anything over here, if I pick any x and then go up or down, I never hit my function. So the first time that happens is when I choose x to be 0. So I can say x equals 0, and that's I'm on my function. But if I do a little bit more than 0, well, yep, I can draw a line up and down, and it touches my graph. So that's part of it. This work, yeah. In fact, every x value from here onwards, I can draw a line up from there and run into my function. So the domain would be x such that x is greater than or equal to 0, because that's actually what I'm allowed to plug in here, and that's what I see on my graph. Now the domain, the domain is the x's. The range for this would be the y's, and you do the same thing on the y's. You pick a point on your y-axis, but now you make a horizontal line. If it touches your function, that y value is in the domain. If it doesn't touch your function, like here, or like what I did before, then those y values are not in the, I said domain, I meant the range. Those y values are not in the range because they don't touch our function. In fact, the first y value would be when y equals 0, because I touched my function. But any y value above that, I can draw a horizontal line and touch my function. So those actually work. So y such that y is also greater than or equal to 0. Let's look at a more interesting graph. Let's look at this one. Hopefully you can think of the domain, but I'm going to do it here. So the domain would be the x values. This one's not as interesting. Remember, I choose something here. If I can draw a line up or down, then it is part of my domain. If I cannot, then it is not. So that the first time it works is when x is 0, because I can draw a line down and it matches there. So I can say x such that x is greater than or equal to 0, because the first time it happens is when x is 0. Here's the interesting part. The range, remember, you pick a y value. Can I draw a horizontal line and touch my graph? No, so that is not part of the range. The first time that actually happens is when y is equal to -3 and downwards, because I can pick any point here and I can touch my graph. In fact, this actually goes down and out forever. So all of these y values would eventually be touched by the function. So it's actually y such that y is less than or equal to, because we're going down below, less than or equal to -3. I hope that makes sense, but I guess we'll talk about more of that tomorrow. And now I'm done.